standard form. Wow, that is one straight line there. Must be in standard form. Holy cow. All right. So in order to use the quadratic formula, you have to put it in standard form first, which means set equal to 0, which is not quite yet. So solving means you're going to solve for x. First thing we're going to do is set it in standard form. Now here's what I always do. Some people don't need to do this, but I find it helps keep me straight. I'm going to identify A, B, and C because that's what I got to plug into the quadratic formula. What is A?
1.
1. What is B?
-5.
And what's C?
-7.
Okay. So if I plug it into the quadratic formula, which is up here, x equals negative b, which is going to be positive 5, plus or minus square root quantity, so I'm going to write that big old thing there, b squared, which would be what value? It would be, but I'm just going to write it here for this first time, minus, and then I always put parentheses, 4 times 1 times -7, all over 2 times a. So 2 times 1. Now when you're working on your homework, you don't need to write it all out like that if you think you're pretty good at it. So, but for this time, I'm just going to do it. So now I'm going to simplify what's underneath here. What's 4 times 1 times -7? This becomes -28. So then I have, underneath the radical sign, I have 25 minus a minus, which becomes a plus, positive 53, all over 2. Got that? Okay. I can't do much more than this. 53 doesn't have any factors that are perfect squares. So really, all I could do is I could say, you could leave it like this, but I just want you to understand that there's going to be 2 solutions here because you got the plus and the minus, right? So you could say 5 plus the square root of 53 over 2, and x equals 5 minus the square root of 53 over 2. Do you have to write that out? No, you could write it as plus or minus. But I just want to make sure there are 2 solutions to this particular quadratic equation. How many times does it hit the x-axis? Twice. This parabola hits it twice. Okay? All right, let's do this one then. So first you have to put it in standard form, and this is what it would look like if you subtracted 17x and added 25 to both sides. You would get 16x squared minus 40x plus 25 equals 0. Over here, I'm going to identify my A, B, and C. Again, it's a step that might help. You might not need to do it. I like to do it. Okay, so now I'm going to plug it into my quadratic formula. X equals negative b, so that's going to be 40, plus or minus the square root quantity, b squared minus, in parentheses, 4 times a times c, all over 2 times, 2 times 16. That's a times. All right? I'm sure Parker knows how to do that. You can put the quadratic formula in your calculator, correct? Somehow?
Yeah.
And then you can do it?
Yeah, there's a program that we got.
Okay. She had a program?
Yeah.
I don't have it. So,
I can get it to you.
if you guys want to share, go ahead. I don't even have a cord to do that with.
I'll bring it. I'll bring it.
Oh, look what happens underneath there. It's 0. Oh. What's the square root of 0? 0. So really, this part becomes irrelevant.
So it's like 40.
So you really only have one solution which is reduced as 5 over 4, 5 over 4, not 5, 5 over 4. Because 40 over 32 reduces to 5 over 4. So that means I only have one solution, which means, where is this on the, how many times does it hit the x-axis? Once at the vertex. Okay? So it only has one solution. Okay? It's already in standard form. A is 1, B is negative 6, C is 10. All right, x equals negative b, which is 6, plus or minus square root quantity, b squared, which I'm going to jump in and say is 36, minus in parentheses 4 times a times c. All divided by 2 over a, 2 times a, which is 2. Let's see what's going to happen here. I get 36 minus 40, which is negative 4 over 2. So as a side note, let's just think about what's going to happen to this square root of negative 4. I can automatically pull out a what? I. If I pull out an I, then I still have the square root of 4, which is what? 2. So this simplifies to 2i, doesn't it? Can y'all see that? Okay. So then my answer is going to look like this. 6 plus or minus 2i over 2. But wait! We can take it further than that. What can we do? I can split it like this. If you need to see it, this is what I was going to do. What's 6 divided by 2? 3. 2 divided by 2? 1. So it's just 3 plus I. And then if you stuck in the minus, it would be 3 minus I as well. Can you see that? Okay, now, because this has an I in it, we have 2 imaginary solutions, which means the parabola is in the complex plane. So you would just say 2 imaginary. Yep. 2 imaginary solutions. Okay? Find the discriminant of the quadratic equation and give the number and types of solutions of the equation. And you can do that just from the discriminant, which is the part underneath the radical sign, b squared minus 4ac. Again, I'm going to put parentheses around here. Based on what you get from the discriminant, again, you can say what kind of solutions there are. So a is 1 for this one, b is 10, and c is 23. I'm going to just plug it into this part. So 10 squared minus 4 times 1 times 23. I get 100 minus 92, and I get a positive solution. Over here in a little box, I'm going to have you write this, because I don't know why it's nowhere on these notes, and I don't know why. If the discriminant is greater than 0, if the discriminant is greater than 0, you have 2 real solutions. I abbreviated the word solution as SOLN. If the discriminant is greater than 0, you have 2 real solutions. If the discriminant is equal to 0, you have 1 solution, 1 real solution. If the discriminant is less than 0, then what do you think you get? You get these imaginary solutions. You get these 2 imaginary solutions. Okay? So this turned out to be greater than 0 or positive, so I can say 2 real solutions here. Okay, A is 1, B is 10, C is 25. If I plug it into B squared minus 4AC, I get 10 squared minus 4 times 1 times 25. Can you see what's going to happen here?
Yeah, that's good.
100 minus 100, which is 0. So I can say, how many solutions are there? One solution. Basically, that means the vertex is right on the x-axis. Can you imagine what's going to happen here? Yeah, so I'm just going to do b squared. I'm not even going to identify. 4 times 1 times 27. You get 100. I didn't do 4 times 27 is 108, isn't it? Negative 8. So you can say 2 imaginary solutions. It would be 1 real, actually. Just to be clear, it would be 1 real solution. Because it would be sitting right on the x-axis. Your vertex would be. Either would want you to use a quadratic. What could I do to this to solve this? What would be the easiest thing to do? You could use the quadratic formula. But I think you could take out a t, can't you? From each term? I'm just playing here. Let's see if this works. If not, we can always fall back to the quadratic formula. See what I did? Yeah? Okay. Now I have a factor here, and I have a factor here, and I have to set them each equal to 0. Let's see what happens. T equals 0. That doesn't help. That makes no sense. You can't throw the ball in 0 seconds, correct? So this one doesn't work, but I think this will work. Subtract 55. Negative 16t equals negative 55. Now what do I do? Divide by negative 16. Somebody tell me what you get when you do that. I think we're going to get the right answer, so you don't even have to use the quadratic formula for that one.
3.44.
Yeah. So t is approximately 3.4 seconds. That is the answer. So sometimes you just got to look at it and say, what's the easiest way? I did not write down your homework.